Here's 2012 question 4, another miscellaneous question. It doesn't really belong to any of the FRQs, but when it's miscellaneous, it's really dry in the sense that there is no context. So in that sense, it does make it a little bit easier. They're really looking at your analytical skills, okay? So here we go. They introduce a function f, which is the square root of 25 minus x squared. And then they ask you to find the derivative. Find f prime of x, okay? So here we go. F of x, I would originally rewrite it so that the square root looks like a 1/2 power, okay? So how do I find the derivative? There is a function inside of my square root function. So this is going to involve, right, the chain rule. So it's going to be the derivative of the outside of the same inside times derivative of the inside. And that's it. Okay, the scoring guidelines cleaned it up a little bit. For now, we're done with part A. Now, if we do need to simplify for future parts of the problem, we'll do it at a later time. But as far as that goes, you guys get 2 easy points right there. Okay, part B. They want you to find the equation of a line tangent to the graph of f. This pops up every time, you guys, okay? Remember, an equation of a tangent line, you need 2 things. You need a point and a slope. So we know the x-coordinate is -3. So how do we actually find the y-coordinate? So if we're trying to find the line tangent to the graph of f, so if I plug in -3 here into f, I'll get the square root of 25 minus -3 squared. That's going to give me the square root of 25 minus 9, which is the square root of 16, which is 4. That is your y-coordinate. So now we have a point, but we're missing our slope. So remember that slope of a tangent is really just derivative, which is what you just solved for in part A. Okay? Now, what I'm going to do is I'm going to find f prime of -3. So I'm going to go ahead and plug in -3 into x here. I'm going to have 1/2 25 minus -3 squared to the 1/2 negative, sorry, times -2 times -3. Okay? So this gives me 1/2 times, if you work on the inside, it's 16. Over here is going to be a +6. Remember that negative exponents will turn it into fraction, and that 1/2 power is really just the square root. But here's the thing, I'm going all the way through. I'm getting 1/2 times 1/4 times 6. And I'm getting 6 over 8, which is really just 3 over 4. You could go all the way through, but really, the moment you plug in your 3, you're actually done. Equal is equal, okay? So you actually didn't have to do any of that right there, okay? Now, the downside to it is, if you leave it, right? If you leave it, your slope is going to be really messy, so your equation of a tangent line is going to be really messy. So what I'm going to do is I'm just going to use the value just for the sake of cleanliness. We now know that the slope is 3/4. So the equation is just y minus y1, which is 4, equals the slope times x minus x1. You could put x plus 3 if you want to, but again, equal is equal. There you go. The scoring guidelines brought that -4 over, but you don't get any extra points for that, okay? Part C, they're asking us to take a look at this new function g, which is a piecewise function that actually includes f, okay? And then they're asking you, is g continuous, okay? So this is just like 2011, I think it was question 6. To prove continuity, we have to show what happens with the three conditions, okay? Now, in this case, they're not telling you that it's continuous. They're asking you if it's continuous here, okay? So what you want to do is you want to see if it's continuous at -3. So what you want to do is you want to find the limit as x approaches -3 from the left and from the right, okay? Now, if you're approaching -3 from the left, you're approaching it where all values are less than -3. If you take a look here in this inequality, x is a little bit less than -3, so you know when you approach it from the left, you have to approach f. If you want to approach -3 from the right, you have to be a little bit larger, so in this case you would use that second function x plus 7. So this is just to explain how the scoring guidelines are set up. To find the actual limit, okay, remember the first thing you do is you try to plug in the number. If I plug in -3 into x, I actually do get a value. It comes out to 4. Now, if I'm approaching -3 from the right, we actually have to use that x plus 7 function. And again, if you plug in -3 into x, you get 4 as well. So what does that tell you? That tells you that the limit does exist. The limit is actually 4, okay? So that is actually our first condition. The second condition is to find out what the defined function is, what the value is. So we actually want to find out, well, what's g of -3? A defined function is the exact value, okay? So exactly at -3, whereas limit is really just getting arbitrarily close. So if you look at your inequalities here, when we're looking exactly at -3, we're actually here on the top function, which is f of -3. And we know that if I plug -3 into f, I actually do get 4 as well. So this is our second condition, okay? We actually know that the function is defined. So the third condition is, well, are they equal? If you notice, they both equal 4. So they are in fact equal. So all three conditions were met. So therefore, we could say that g is continuous. You can't just say g is continuous without any justification. You need all three conditions to be met in order to get these points. So just keep that in mind, okay? Part D, last one. Find the value of this integral. Okay? Very random, but really, again, they're testing you on your analytical skills. Right away, I notice that there is a function inside of a function. There's no way that I could integrate this just simply. But I do notice that the 25 minus x squared is inside of your square root function. Where am I? I lost myself. Okay. The 25 minus x squared is inside of your x squared function. So what I'm going to do, let me go ahead and write that out here. The square root of x times 5 minus x squared, 25 minus x squared to the 1/2 dx from 0 to 5. So right away, I know u has to be the inside function. So I'm going to let u equal 25 minus x squared. So du would be the derivative. I would just get negative 2x dx. So here's what happened so far. I am going to substitute 25 minus x squared for u. Okay? So as of now, I'm going to have the integral of u to the 1/2. But the thing is, I still have an x dx left over. And it's kind of there in the du. So what I have to do is I have to kind of tailor it. So x dx, if you guys isolate it, if you divide the -2, that's just going to be negative 1/2 du. So here, now I have a perfect fit. So I'm going to go ahead and substitute that for negative 1/2 du. But the negative 1/2, I could actually just throw on the outside. Now here, if everything is in terms of u, that means your bounds have to be in terms of u as well. So notice how your limits or your bounds are currently at 0 and at 5. This is when x is 5 and this is when x is 0. So what you do is now, what if x was 0? If x is 0, then u comes out to actually 25. So your new lower bound is actually 25. Now, what if x was 5, right? What if x was 5 here? 5 squared is 25. 25 minus 25 is 0. So your new upper bound is going to be 0. Now here you actually have an option. Most people will try to flip the bounds, and you can. Just consider putting a negative on the outside. But you don't have to. You could just integrate this, plug your upper minus your lower, but I think most people would want to switch anyways. So what we want to do is we're going to reverse those bounds, but then you have to consider that a negative goes on the outside. So the negative that goes on the outside ends up being a positive 1/2. Okay? This is way easier to integrate than what we started out with. Okay? So this is going to be positive 1/2. The integral of u to the 1/2 is just going to be u to the 3/2 over 3/2. Okay, from 0 to 25. Still, there's a little bit of calculus left, so we have to keep going. This is going to come out to positive 1/2 times 25 to the 3/2 over 3/2 minus 0 to the 3/2 over 3/2. I wouldn't even simplify it. Equal is equal there. That's enough for you to get your points. Even with a 0, I plug in 0. Oftentimes it goes away because the whole problem goes to 0, but there are some cases where 0 doesn't make it go away. So I just plug it in and I leave it. But that's basically it. If you take a look at this whole problem, it was really just analytical skills. Purely analytical, so it's an easy way to get your points.